Okay, today we're going to talk about Python lists. Lists are a basic part of Python that let you store data in a sequence. Here's a list. Okay, so as we can see, this list has the items 1, 2, 3, and 4, all integers, stored in it in a row. So if I wanted to print the whole list, I would just type print L, but I can target each item if I wanted. I could say print L0, print L1, print L2, print L3. And we'll build, and as you can see what it gives you, right here, I define the list, I print the whole list, and then I print each item individually. And as you can see here, the way we access each item in the list is by referring to the name of the list, and then you give it some brackets and put an integer inside those brackets. The first item in each list will always be referenced with the integer 0, and that's just because it's sort of a traditional thing that's gone on for a long time. But basically the idea is that you're moving, like L is where the data starts, and the number that goes in this bracket here is the number of offsets from the beginning of L that you need to do in order to get the item that you want. So if that makes no sense to you, don't worry about it at the moment, but basically if I want the first item in L, then I'd put in 0 because L basically starts at the first item, so we go 0 offsets. If we want the second item, 2, we'd go 1 offset in order to be basically at 2. Right? So that's how you would get the individual values in the list. But if you wanted to, let's say, loop through a list, you can use the for loop construct. So for item in L, print item. Alright, so if I build this, well, let me get rid of some of this junk here. Let's try this. Right, so it'll do the same thing I did before, but instead of having to type print L0, L1, L2, L3, what I can do is iterate through L, because L being a list adheres to a certain standard of manipulation called the iterator protocol. But it basically lets you take a list of items and treat it as a stream, and you can go through the stream and get each item in a row. And notice it's not the index that it's giving us back. This item variable stands for the actual value. So if we changed it to like A, B, C, D, let's rebuild that. So A, B, C, and D, you notice that the item that we're getting back is A and not like 0, right? And B is, we get, the next time around we get B, we don't get 1, right? So what we're getting back is the actual values in the list. So lists have also some cool things that we can do with them. You can, and these cool things are more technically known as methods, which are basically functions attached to some sort of structure like a list. Let's see. If I want to add something to L, I can do it with the append method. So I type L, and then a dot, and then the name of the function that's attached to L, right? So if we build this, see this new value, E, is now at the end of my list. So that's the append method, and what that does is it basically puts it at the end of the list. Another term you might use to express the same thing is push. So push would be basically adding an item to the end of the list. And So instead, and the sort of inverse of append is pop, right? So when we do that, let's see, I'm going to clear out some of this. So if I run lpop on a list that has A, B, C, and D in it, it should basically remove the last item and only give me A, B, C. Let's see, A, B, C, yeah. But we can also save the result of l.pop, and then we can print our list, and then print saved list item. And what that will do is basically we will be taking off the last element of the list, but we also will be saving that, or basically referring to that value, and thus keeping it alive. And we'll refer to that value under saved list item. So if we print L, we'll see that L is still is no longer ABCD, it's ABC because we popped the last item. But then we can print this saved list item, which will basically be the item we popped. So it's not part of L, but it is still accessible to us under the name saved list item. Let's go ahead and check that out. So right, A, B, C is our list, and then D is the fourth item that we saved. Right. So let's see. We've learned basically how to index in a list, right, to get a specific element. We've learned pop. We've learned append. And let's see, what else do we need to know? There's also some handy notation for printing out subsequences of a list, also known as slices. So if we do, so we can put this colon in here, and what that means is basically there's a start field and an end field. And so what we can do is replace start with some index of the list, and it will start on that index and basically give me all the elements up to but not including this end index. So if we did 0 and then let's see, this L has, let's just treat L as this list now. So if we print, this basically will give us, it's the same thing as printing L, because what we're saying here is give me basically everything from the first item, and then if you leave the second field blank, it's just the rest of the list. So it's sort of, these are equivalents, and you can see that here, right? A, B, C, D, A, B, C, D. But if I wanted the first element, if I wanted to start at the first element and go to the end, then you would see that this print L, where we have the from the first to the end, gives us B, C, D, and printing the entire list gives us A, B, C, D. So you might think like, okay, well, I guess what I mean to say is that I want to draw attention to the fact that these slicing, basically the slicing doesn't modify the list itself, right? So after we do this one, give me this subsection of L, right? And then we print L again. Notice that L hasn't really changed since we first assigned values to it. So what this list slicing syntax does is it gives you copies of the list, but it doesn't modify the actual list.